Hello, I'm David Valdés, and today I wanted to talk to you about roots and just give you, in this introductory video, a brief definition. So here we go. Let's call a root essentially the value r such that r raised to a power n equals m. So whatever this guy is raised to a power equals something else, and the root is just the r guy here itself. So let me give you an example of that to illustrate this definition, since this may not be the most common definition you see, at least right off the bat. Suppose we had a square that had side lengths of 3 inches and 3 inches. Okay. And what we're interested in is the area here. The area of the square can be calculated by length times width, or side times side, 3 times 3 in this case, which comes out to 9. Or we could have said that 3 squared is equal to 9. And so if we're asking ourselves, what is the root of this area, 9, and I should also say that this is 9 inches squared, or square inches. If I'm asking myself, what is the root of this area of 9 inches squared, the root here, by this definition I have above, is 3. Why? Because that is what was squared to produce 9. So we'll call this the square root in this case. All right. And in words, I could say that 3 is the root, I should say square root, write that above. 3 is the square root of 9 because, and here's the essence of it, because 3 squared is 9. 3 squared is 9. Okay. So, and given the dimensions, we would say the root in particular is 3 inches. Let me give you another example just to go along with this idea, and again, using that definition. Let's consider the next higher dimension. Suppose we had a cube. Okay, that's a quickly, sort of poorly drawn cube, but you're keeping in mind that this is a cube. And suppose we said this is 2 centimeters by 2 centimeters by 2 centimeters. Then we can state the volume of this cube as length times width times height, 2 times 2 times 2, which gives us 8. And in this case, since all our dimensions are centimeters, we have centimeters cubed, or cubic centimeters here. And suppose I run this machine backwards and I'm looking for the root of this volume. Okay. Well then, we can say that 2 cubed is equal to 8, noticing that 2 times 2 times 2 is 2 cubed. By the above definition, just kind of the basic idea of roots, this guy right here, number 2, is the root. And you can see it in the diagram and sort of start to internalize what I mean by roots, what we mean by roots as a whole. So I'm going to call this the cube root, since it relates to a cube. You could call it the third root, since it relates to a third power. If you're looking at some sort of 4-dimensional thing, which is pretty impossible to draw, although maybe you can get creative, then you say a 4th root, or 5-dimensional, then you say a 5th root. So this, we're going to say the cube root, and the cube root is 2. So in words, just like I did here, we could say 2 is the cube root of 8, because, and I'll leave a little space here, 2 is the cube root of 8, and here is the essence of it, because 2 cubed is 8. And that's really the definition of roots. In the next video, I'll get into the symbolism and evaluation of roots and start to run into things that you more commonly see as you're going through a math course. So stay tuned for the next video.